Okay, hello again. We're going to be going over the rules of exponents, specifically the product, the power, and the quotient rules. These are the three most commonly used rules of exponents. Okay, so we'll start with the product rule. Product means multiply. So this is when you are multiplying exponents together, such as x to the third times x to the fifth. Okay, and the rule for this is that you simply add the exponents together. So if I have x to the third times x to the fifth, that would simply be x to the eighth. The reason for this is because x to the third means that, x times x times x. X to the fifth, same thing with 5x's multiplied together. So if I take x to the third and multiply it by x to the fifth, I'm basically multiplying x times itself 8 times. So that's the reason that we add the exponents. Adding the exponents is a shortcut, but this is the reason behind it. We can do this as long as the bases are the same, meaning this is x and this is x. If one were x and one were y, you'd have to just leave them separate. Same if they're numbers. If they're both numbers, like if we have 3 to the 5th times 3 to the 9th, we can apply the product rule as long as those bases are the same, and that'll become 3 to the 14th power. Okay, but if one was a 3 and one was an 8, we could not do that. So as long as the bases are the same, whether they're numbers or letters, you simply combine them together and add the exponents. That's the product rule. Okay, we'll do the power rule next. So the power rule is when you have a power basically on top of a power. So if you have x to the third squared, and it usually looks like that. The power rule says that we multiply the exponents together. So we can combine them together, but now we're going to multiply the exponents together. And the reason for this, I'm going to show you the long way again. X to the third squared, anything squared, it's like taking x to the third and multiplying it by itself, because that's what squared means. It means take whatever's inside that parenthesis, which is x to the third, and multiply it times itself. And then we just learned, because of the product rule, that this is x to the sixth. Okay, I can break it down even further. X to the third means x times x times x. Another x to the third, and if I multiply those two x to the thirds together, I'm essentially multiplying x times itself 6 times. So this is the reasoning behind it. This is the shortcut. The shortcut says we take those exponents and we multiply them together. Okay, last one is the quotient rule. And again, those bases have to be the same. For all of these rules, go back real quick. So if that were an x and a y, won't work. For these, all the bases are going to be the same because it's a power. So even if it's a number, we can apply the same rule. If we have 3 to the 5th to the power this time, the rule is you multiply those exponents together. 3 to the 35th. I would never ask you to solve that. You'd write it as 3 to the 35th. Okay, last quotient rule. Quotient rule is division. Sometimes you will see it written as division, so x to the 5th divided by x to the 3rd, perhaps. Sometimes you will see it written as a fraction, because that's just another way of writing a division problem, is to write it as a fraction. Those two mean the same thing. So you have to be able to look at it both ways. The rule here is that we subtract the exponents. We subtract the first minus the second, or the top minus the bottom. So what we're going to do is subtract the 5 and the 3. So our answer here is x to the second. Okay, and there's a couple of ways to think of it. Really, the easiest way is to look at the fraction form. And if I break this fraction up into x times x times x 5 times over x times itself 3 times. So I just changed the x to the 5th and the x to the 3rd and expanded that. Every time you have the same thing on the top as on the bottom, it cancels out. Kind of like when you have a 3 over 3. That's just 1, right? So an x over an x, it doesn't matter what that number is, if it's 3 or 5 or 28, x divided by x is just 1. So you can kind of cancel. X divided by x here is just 1. Technically, there is a 1 that's being left there. So they're not going away. They're all becoming 1s. That x and this x cancel out and become 1. So every number or letter on the top that's also on the bottom cancels out and becomes 1. And anytime we're multiplying 1 times 1 times 1, we don't have to worry about that. On the top here, we have 2 times x. That means x squared is our numerator. And on the bottom, I'm going to do this, we have 1 times 1 times 1. So the denominator is 1. Now, of course, we don't have to write a denominator when it's 1. If it were 1 in the top, the numerator, you do need to write that, though. Okay, in this case, we don't. The answer is simply x squared. So that's the reasoning. I want to show you this with another example where they actually have the leftovers on the bottom. So let's look at if it were backwards. Let's say we had x to the third divided by x to the fifth. Okay, that's the same as having an x to the third in the numerator and an x to the fifth in the denominator. So if we do the canceling in this case, there's 2 ways to go about doing this. We have x times x times x on the top, and on the bottom we have x times itself 5 times. All right, every x that's on the top will cancel with 1 that's on the bottom. So I'm going to cross them out. That cancels with that. Put the 1. It's helpful. This one will cancel with this one. We'll replace it with a 1. This one will cancel with this one. We'll put it with 1. And then we don't have anything else left to cancel. So when I write my answer here, I have 1 times 1 times 1 in the numerator. So my numerator is 1. You have to put it. On the bottom, I have 1 times 1 times 1 times x times x. That is just x squared. You don't have to put times 1 when there's something else there. So this is my answer, 1 over x squared. This is how you need to write your answer, like this. There is another way to look at it. If we use the shortcut, remember I told you in the previous example, it's the first exponent minus the second exponent. So it's the 3 minus 5. So if we do it this way, we still get the correct answer. It's just in a format we don't usually write. The answer here is x to the negative second power, which is correct. And we will talk about negative exponents later if we haven't talked about them already. But these two answers actually mean the same thing. An x to the negative second simply means a 1 over x squared. They mean the same thing. And that'll lead us into negative exponents if we haven't already discussed those. So one more example with the quotient rule. Let's take something that has a couple different. Let's say we have this. Usually you'll see it written as a fraction. And for now, I want you to practice doing the canceling rather than subtracting. That way we're not dealing with negative numbers. So if we use the method of canceling, I'm going to expand this out. X to the third is x times x times x. And then we have a times y. Remember, they have to be the same letter or number to do any canceling. On the bottom, I have x squared. And just so it lines up nicely, I'm going to line up the y's starting on top of this y. All right, same letters cancel on top and bottom. So this x can cancel with this one. This x can cancel with this one. Remember, replace those with a 1. That one doesn't have anything to cancel with. This y can cancel with this y. Replace it with a 1. And that's all that can cancel right now. So what we're left with, on the top, we have 1 times 1 times x times 1. That leaves an x on the top. On the bottom, we have 1 times 1 times 1 times y times y. So y times y is y squared. And that's our answer. So we write that answer as x over y squared. Okay. And that is the rules of exponents. The product, power, and quotient rules of exponents. Later on, we'll talk about negative exponents, zero exponents, and a few other things.